Today, I decided that I wanted to do a follow-up to my calculating the average distance between 2 points on a line combinatorically video. And today I wanted to calculate the standard deviation of the distances between points on the unit interval. We're going to use the average that we got in our last video to help us calculate the standard deviation. Here's a quick example of how we were able to calculate the average distance between 2 points on a line. We have n evenly spaced points. Then we take all subintervals on that line and add up all the distances and then divide by the total number of intervals, and that gives us the average distance for when we have n evenly spaced points. In this example, we have n equals 5, and our average distance we can calculate out to be 1/2. We then do the exact same process when we have n points. We break it into subintervals, then we sum up all the lengths of these subintervals and divide by the total number of intervals. And we did that in our last video. It ended up being 1/3 times n plus 1 over n minus 1. And that was our average distance between 2 points when we had n evenly spaced points. And then we took the limit as n went to infinity to find out what our average distance would be when we had infinitely many points. Now we're going to use that result to help us calculate the standard deviation of the distance between points on the unit interval. Here are our formulas. Variance equals the sum of the difference between our length and our average length squared divided by the total number of points. Our average is 1/3 times n plus 1 divided by n minus 1. Our total number of intervals is equal to n choose 2 because we need to have 2 points to make up an interval. And lastly, each one of our lengths, we can see here, the first one is 1 over n minus 1, the next one's 2 over n minus 1, 3 over n minus 1, all the way through n minus 1 over n minus 1, which is just 1. And now we're going to plug everything into our variance formula. And when we do that, we get this very long expression down here, which I will explain where all of these numbers come from. The number on the outside of the brackets is the number of lengths that we have. So for 1 over n minus 1, we have n minus 1 of those. For 2 over n minus 1, we have n minus 2 of those. Then the number on the inside, the 1 over n minus 1, that corresponds to the length of that unit. The 2 over n minus 1, that corresponds to the length of that unit. And then the n plus 1 over n minus 1, that is our average. So we're just plugging everything in to our variance formula and condensing it down and getting this nice long sum. The trick that will help us figure out what this sum is to look. On the outside we have an n minus 1, and then on the inside of our first bracket we have a 1 over n minus 1. Then for our next term we have an n minus 2 on the outside and a 2 over n minus 1. And then for our next term we'd have an n minus 3 on the outside and a 3 over n minus 1 on the inside, all the way down to an n minus 1. So we have an n minus 1 on the outside and an n minus 1 on the inside. So in general, we can write n minus k on the outside times and then a k over n minus 1 on the inside. So that way we can now write this as a sum from k goes to 1 all the way up to n minus 1. So now we have this annoying sum from k equals 1 to n minus 1. But we can actually solve this, and to do this I'm actually just going to go to Mathematica and plug it in and see what it spits out. But we could actually do this by hand if we were really motivated. We would just have to FOIL out everything and then group everything in terms of k, we should have like a k cubed, something k cubed, plus something k squared, plus something k, plus a constant. And then we have formulas for the sum of k cubed, k squared, k, and a constant. And then we just have to figure that out and then FOIL out everything. But I just decided to use Mathematica since that was something that was available to me, and it just simplified down a whole bunch of algebra. Mathematica spat out that the answer to this sum was n cubed plus n squared minus 2n divided by 36 times n minus 1. So that is really nice. We've figured out the first half of our standard deviation problem. This n cubed term is only the sum of the xi minus the mu squareds. So to get our actual formula, we have to divide by the total number of intervals, which is n choose 2. Once we do that, we get n squared minus n minus 2 divided by 18 times n minus 1 squared. And that happens to be our variance. Now we're going to take the limit as n goes to infinity, and that will spit out 1 over 18. So our variance is 1/18th. And lastly, to get our standard deviation, we have to take the square root of our variance. So the square root of 1 over 18, that's the square root of 1 divided by the square root of 9 times the square root of 2, which is 1 over 3 root 2. So finally, we get that the standard deviation of distances on the unit interval is 1 over 3 root 2. So now we know the average distance between 2 points on the unit interval is 1/3, and the standard deviation of distances on the unit interval is 1 over 3 root 2. That's everything, so thanks for watching.